So, before I move into the TileMap system, since the last of the class last time was talking about enemy controller and the token controller, I'm just going to wrap that up. So, enemies. Let's go back to an enemy. Why is he right on this? Oh, because I'm showing gizmos probably. Yep, okay, because the TileMap had to turn to show gizmos. So this is a basic enemy prefab that's been instantiated as a game object in our hierarchy. You place it somewhere, so it's got some data in its transform. Yeah, it's got a sprite render. There's the default image. We have our animator. And this is some of the... I just wanted to wrap up the conversation that, yes, there's an animator. There's different animation states, just like the player controller. There's different parameters that are being kind of driven by the enemy controller. They're being updated. And as these are updated, in fact, maybe if I just click play, based on what these parameter states are, designates what state we get placed into, transitioned into. So here is an enemy that's running back and forth. It's in the run animation. There's a velocity X. You see the position in the transform is changing. The sprite render is changing. Basically, we're running through all the sprites that are in the run animation. And you see flip X is turning on and off as he's bouncing back and forth. This enemy doesn't have a patrol path. It's staying in idle. And notice that the sprite render is flipping through the idle animations, and we're not moving. There does seem to be like just a slightness of movement. That's probably coming from the animation controller, which I'll cover in a minute. And when in all of these things are being governed by the enemy controller. They're like writing to these all the time, which is governing what animation state we're in. And those animations are sprites that are sitting out in our project, and the animations are tiles that look like this. There's keyframe animations. So besides sprite animations moving back and forth, like this is the idle, it looks like there's some animations on the enemy size in something with the collider. So the collider position and the size of it has just a very... Not that size. Oh, because it's jumping. I see. So this enemy jumps during its animations, and as you notice, the capsule collides pretty... Usually in a game you'll notice that like you might, when an enemy does something like this, like it's kind of, you'll like move through the graphics, but you won't have like what you would consider to be the correct collision. But this one is animating the capsule collider to stick with the top of it. So that's actually, that's good. Slick. So sprite render, animator, the rigid body. So the collider is used for the collisions, and if you remember in the enemy controller, this is the on collision enter 2D. This is something coming from the physics system that if there's a collider component sitting there on this game object, it'll listen to it and say, hey, there's a collision, what do you want me to do? And so the enemy controller is managing that. And in this one, normally there isn't a health script, but we did modify the whole situation so that you could slap a health script on it and increment the health if you wanted to. So what was left with the enemy controller? So when it starts, it awakens, and you either manually assigned a patrol path or you didn't to make it move, and everything else gets connected on awake, and then there's a collision event. And on update, if this path thing is not known, there is a path patrol we should be following, then it has to check if there's that mover. It's like an internal class to the path controller. Like if there's no mover class, we have to create one at this speed. And then every update we get the position X from the mover, and we get the difference of that in our current transform position, our transform component, what its position is, and whatever that difference is, it better be between -1 and 1, or else we'll clamp it. So basically it's saying like every update frame, we can only, it looks like we can only max out our movement like to the left or to the right, like 1 unit. Doesn't want it to go any faster than that. And then ultimately this all goes over to the animation controller, which, so it looks like the process of how to move an enemy is, first is there a patrol path here, and if there is, then we have to end up creating this mover, and it's this mover that gets referenced every update frame. In fact, it's this position here. It just calculates this thing. Remember I was talking about how ping pong goes back like 0 to 1, 1 to 0, 0 to 1, 1 to 0, back and forth, back and forth. 0 to 1 is just an important, it's called interpolation. Like I'm 0% of the journey up to 100% of the journey, and anything in between. And so ping pong is just saying I'm starting at 0, going to 1 or 100, moving back to 0, back and forth. It does all that calculations for you. You just say, hey, here's where my current time is. This is how long my animation, my movement between A to B or 0 to 1 is supposed to be. And then you figure it out from now on to like infinity. And then they did this inverse lerp, which is saying the regular lerp, which is you should become accustomed to, is, hey, I'm moving from points A to B, start to finish, and I'm this far in my journey T. So I'm moving from A to T and A to B, and I'm T as far into my journey. And then when you say that, I'm saying, here's my start position, here's my end position, here's how far I am. And then the equation, the method says, okay, well, here's where you currently are. And we do this a lot in programmatic animation, programmatic motion. And it's called linear interpolation. And the animation system does it a lot. It's saying, I want to point here, and I want to point there, and you tell me in between. In fact, that's how these animations are working. It's like the same thing. It's saying, I have a point here, and this time, and I have a point here, and this time. So in this case, it's saying the size of the collider in the Y is going to be at 3.952 at this time. And if we just come a few frames in, 3 seconds in, it just moves a little bit. And if we go farther in, 16 frames in, we're moving this far in. But I don't do the math in between this. The computer is linearly interpolating between the points A to B, and whatever T is, as I move this, it figures out what that number should be between the two. And if you look at the curves, this is what the curve is doing. I've placed this point, and I've placed that point, and the computer can figure out everything else between that. Sorry, I saw there's a comment. Let's take a look. Yeah, this is all built in. Yeah. Anyway, yes. So MathF is a library, uniengine.mathf, and MathF has a lot of helpful stuff like clamping, cosine, sine, how to, like angles around a circle, flooring and ceiling. Like go to the, if it's a decimal number, drop it to the integer or raise it to the integer. Is it a power of 2? Like powers of 2 we use a lot, and you can figure out if it's power of 2. Logarithms, log 10, min max, give me the min and max of 2 numbers. Perlin noise is super useful for creating noises that look like something like clouds. And then there's ping pong powers. So anyway, math f dot ping pong. Yeah, part of the F meaning float. It's a math float library. And also note that lerp can be from math f. There's also a lerp for vector2 and vector3 because it's just used in those situations so much. So ping pong between 0 and 1 over whatever time we are during the runtime. And we pass this into the inverse lerp, which takes A to B, our start to finish, but then we pass in a point between that journey, and it tells you where we are in our journey. So I've started here, finished here, and I'm at this position between my journey. Where am I? And then that's what they use to pass into the lerp, which is that t value. So I know it's lerping and inverse lerping and ping pong. Like lerping took me a while to wrap my head around, but it's used a lot. So, and you'll probably see it a lot in the first-person shooter. Cool. But anyway, the patrol path, the mover class in the patrol path is ultimately figuring out, hey, as this like enemy is patrolling left to right, left to right, left to right, where are we in that left to right at a moment's notice? And that's what the enemy controller is saying. Hey, every frame, hey you, mover, go out and tell me where this enemy should be moving. Take the difference from that to our like where we currently are to where we're going to be, and then like pop that into our animation controller. So it's kind of like the enemy controller starts things off. It goes to the patrol path to figure out where it should be going, and it tells the animation controller ultimately this move, this vector 2 is getting updated. So with the player, it's interesting, this animation controller is being reused. With the player, the user input actually updates this. You know, if the user is pressing left, right, it'll update that X value in this vector 2. But here with the enemy controller is going out to the patrol path to figure out where its next position should be, and it's updating animation controller. And this thing is ultimately, I don't even, yeah, this stuff is definitely happening. The animator, it's like updating the animator. Is it moving? What its velocity x is? Is it grounded? Should we be flipping the sprite render? So the animation controller is manipulating the sprite render component. It's manipulating the animator component. But ultimately, it's like ba-da-ba-doo, doing some calculations. Here's the move that gets updated. And ultimately, it's updating this target velocity. And that's part of, you have to look up in the parent class, unfortunately, to like continue seeing where this processing is happening. And compute velocity, fixed update. So here in remember update deals mostly with user input. And once like move and target velocity gets figured out, it looks like it gets zeroed out and then it gets computed. And this is empty here because it's a virtual function. It gets filled out in the animation controller. Anyway, fixed update gets hit after the next time around, and here's that target velocity coming in from animation controller. And so we take that X, so we throw it over to here. And then this is impacting the rigid body, the physics, the rigid body. So it's giving velocities to it. So all the way down here, after it does all this calculations, the body position, the body is the rigid body. So the position of it, so it's not doing acceleration or velocity, it's just updating the position. Pulling in like all these calculations of what should be moving and where we currently were, update it with this new change, and then update our position. And so what that is doing is the animation controller ultimately is like setting the position of this rigid body. Usually, like you'll see in the go-karting, the karting example, the others, how like you take a rigid body and you either add a velocity to it or you add an acceleration to it, and let it do its thing. Let it just like do physics simulations to move it. This one is just like updating the position of it. It's saying, hey, here's our new position, our new world position. Then rigid body is just kind of updating the transform position. Ultimately, this is like our blob moves, the position here changes, and that's where it gets changed render-wise. And cool. I just wanted to finish talking about the enemy controller, which are the enemy controller, the animation controller, and how it's impacting the animator, the sprite render, rigid body, and ultimately the transform. So it's complex. The good news is once you like, you feel like these are like very complicated topics, but if you spend a lot of time with them, you're able to like break them down into smaller, simpler steps. The good news is a lot of the other stuff starts making a lot more sense because it's like you have to learn these patterns of game programming, but once you start to see how it's working, like you'll be able to apply the pattern. You see the pattern happening like all over the place. It's just kind of like a repeat. It's complicated to look at in the beginning. So, the token. So we were kind of showing that all these tokens have a token instance component object. Looks like they have a circle collider so that they know when the player touches them, and they have a renderer, but they don't have an animator. And that's why I said that this was interesting, because there's a token controller and you can set the frame rate of the animation. And notice that like this list of tokens is empty by default, because who wants to go around and like drag 100 in manually through the inspector? And so the token controller starts up, and I start talking about arrays with the square brackets. And arrays have elements. It's a collection of elements, and you can move through the array and like view. You get access to the element with knowing the index, the position of it. And so on awake, we say, hey, my array of tokens, it happens to be empty. So let's go find tokens in our scene. And that's what this is doing. Just going out, find objects of type. Notice it's not game objects. So I think I'm not sure if it's looks at if it's focused solely on component objects, or if you can find game. It must of type. This is looking for component objects. So you have to have a type. So token instance. Remember generics? These are these angled brackets. This is a method call. And because it has the smooth brackets, but when it has this little thing in between it, like in between the name of the method or the function and its call, this is known as a generic. It's a generic function. It's a generic method. And you can slip any type of type in here, any type of object, and this function, this method will run specifically on that type, that object. And since you can have like, you never know the names of the objects, the classes that the developer creates, you end up using generics to be like, well, put your own, whatever you're looking for, just put it in here. Well, I'm looking for token instances, component objects during runtime that are of type component. Token instances, and it'll return an array of whatever it finds, which might be empty. Tooltips are really good, are really cool. So I just mentioned them briefly. So if I hover over frame rate, I get some helper text, frames per second, which tokens are animated. Look at here. That's the string right here. So whenever you like have a property or something, and if you put something with square brackets, like I was showing you about serialized field, but here if you say tooltip in these little brackets, it'll make a macro command. It'll say, oh, okay, you want this property to have a tooltip in the inspector. What do you want the tooltip to say? It'll say that. So those are tooltips. So this is a different use case for a square bracket. We're not defining a variable that can be of an array of certain types. We're saying this is a macro command. So anyway, we have our array of tokens, and then we loop through. So I talked about the for loop, very important. It complements the arrays and lists very well. And this says, while I evaluate my statements, those are true, I shall run this body of code. So you always start off with an initialization statement. Usually it's saying you're declaring some variable, an integer or a var. These days everyone's getting lazy. So int I equals 0 is normally that, because usually you're starting at the beginning of the array, which is element 0, and counting up. And you say while I is less than tokens.length. Okay, so interestingly, it's not less than equal to. So if the array's size 100, you only want to evaluate elements 0 to 99, because we start counting at 0. So when you start counting at 0, n minus 1 is really n. So if you're trying to get to element 100, element 100 is at index 99, because we start counting from 0. So you only want to say I is less than, so you want to say 99 is less than 100, true, evaluate. So you want to evaluate from 0 to 99, because we're actually going into this array and going into this element, this index I. So we do want to go through tokens I to tokens 99 and do something to them, but we do not want to go to tokens 100, because that does not exist, because that means it would be element 101, and we only have 100 elements. We get an error. So this is common, like go less than the length, because the length would be 100. We have 100 elements, but they just happen to be numbered from 0 to 99. So we evaluate logically. If it's true, we do our work, and then we increment. So we update the iterator. Sometimes it's increment, sometimes it's decrement, sometimes it's something else. But then we don't initialize anymore. We only do this once. We go and check. We change the this variable. We check if it's true. Do it again. Increment. Let's just say it's false. Now it turns to 100. Then we're done. We leave the loop. So it's important to understand the for loop. They've been simplified these days into the for each loop. But as a game, it's any programmer, you need to understand more basic structure too. So it goes through all these token instances and says, hey, your index number is this. So in token instance, here's the token index, which assigns itself to -1, which means it's like invalid. There is no index -1. That's how you check if it's been assigned or not. And then you say, who's your controller? This object of type token controller that's running at runtime. And then token controller is just always keeping track of the time. And if the current time minus the current time that we're at over the last time we did our animation starts getting greater than our frame rate, or went over the frame rate, then we do our work. We loop through all of our token instances, and we tell it to like change its sprite. So what does that mean? each token instance has an array of sprites. So if I go to this token here, token instance, we have our idle, we have our animation. There's 13, this is a collection, 13 elements in our array, 0 to 12. And these are our different animations. And when played back, just like in the animator, just like in the animation window, it looks like an animation, looks like motion. This is exactly how the animation and animators are functioning. That's why I like showing this. So it knows all of its little sprite renders. It needs to play to be able to animate. And I guess if it was collected, it has a different set of animations here. So token controller says, hey, grab me one of these token instances, loop through them all. If it's not null, it's null if it's been taken already. Then go to your render component, and that current sprite that you're on that's being rendered to camera, we're going to set it equal to something else. We're going to change its number. We're going to go into your array of sprites, and we're going to get the current frame that you're on. The frame is, it defaults to 0. We're at position 0 when we start. And so it sets itself to 0 because it's the first time running through. And then at this part I haven't looked at yet. This is if the player grabs it. I'll get to that next. So the frame that we're going to be on, that we're going to animate on next, basically we're setting up for the next update loop where we're going to set the sprite to that number. We take a look at, we increment that number. So starting at 0, 0, 1, 2, 3, then the next update loop we actually swap out our sprite to that next one. But we mod it by the length of our sprite. So I talked about modulus last time, very important concept. For example, 13, we're going to mod it by 13. So 0 mod 13, 1 mod 13, 2 mod 13, blah, 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 blah. Mod is the remainder. So 13 mod 13 is 13 divided by 13. Means there's nothing left over. Like 13 divides into 13, 1, right? So let me see if I get that right. Yeah, that's right. So if we start at 0, 0 mod 13 is going to be 0, just because there's nothing. Nothing's 0 divided by 13. You have nothing remaining, nothing. 1 divided by 13 is 0, but the remainder is 1. And then you have a remainder 2, remainder 3, 4, 5, 6, 7, 12. And then when we get to 13, 13 divided by 13 will be 1 with a remainder of 0. It divides into itself wholly. And then we move to 14, we get 1, but with a remainder of 1. And then 15 equals 1, but the remainder is 2. Because 13 goes into 13 once, and then you have 2 left over, your remainder 2. So it's a little math trick. Basically, we're cycling between 0 and 12 this way. And I said, if you don't understand the math, you can do it with an if statement. But it's good to understand why modulus is used so much. And that's how it's animating itself. Or animating each token. Cool. There's something on. So it's like a mini. There's something else about it I wanted to talk about, but I forgot. Oh, so this list is procedurally generated at runtime, and this list is manually added to. So you just add plus, and you drag stuff in from the assets. So in the assets, it's hard to find stuff programmatically, so you just like build it manually. Cool. Okay, the player hitting the token. So token instance on trigger enter. Go get this whatever hit us. Go get its game object. Try to get a component called player controller. If that's not null, okay, the player has grabbed the token. So call this with the player controller. So if you've already been collected, I guess maybe if the token was collected and it's like somehow still like just playing its little animation to like disappear itself, then don't run it again. Just don't worry about it. You'll be disappeared soon. Procedurally generated. So this is a list, right? I can create another one. So let me just add one more here, like my animation. So I made another array that can be exposed in the inspector. Man, I don't know what Unity's acting slow. Okay. So if I move down here, my animation, it's an array, a list, and it's empty. Now I can manually build it, drag and drop. I can say, okay, I want it to have 3 different sprites in it, and you can go around. I don't know what you can build it. Say I want it to have these sprites, right? So that if I were going to play this animation in my little animation playback, it would play these sprites. So I manually built this array of 3 elements, right? Procedurally or programmatically kind of means the same thing. But here's an array, and I'm not manually building it. I'm not manually specifying its elements. When I click play, it's going to be built by code. It's going to be programmatically built or procedurally built. Procedurally could mean like when you build procedural game worlds and you're just following game rules, like, oh, we're going to have a level, it's going to have 3 rooms, but we're going to randomly like size the rooms and how they connect to each other so that at runtime it's all dynamically built. It's not just built once by a person, by a level designer, and then it gets boring. So you have it procedurally built so that it's like variable and the player doesn't even know what the level's going to be like when they start. So programmatic and procedural are very similar. So this would probably be more like it's programmatically being built. With my program code, I am building this array. And what that means is really what it means is on awake, run this code. Hey, Unity, go out into the hierarchy and find me all component objects of type token instance and build an array from it. So Unity did it for me. It went through all these and said, yep, here is a token instance component object. Here's a reference to it. It went through all that. It did it programmatically. So token instance, player hits it. Yeah, you try to do everything by code. So there's like not like a meme or something, but it's like a joke that, like programmers and engineers are lazy. Our good engineers are lazy, like because they engineer everything. They don't do anything manually. They like, nope, I won't even build this with a GUI. I won't even take 10 minutes. I'm going to go figure out how to write a script and do it for me. So I think there's a fine balance with that. I think you need to know when to build stuff programmatically, when to do it manually. And you learn a lot too when you build stuff manually. And then when you know what you want to build, then you do it programmatically. And procedural is just kind of a riff on it, like procedural level design and stuff. It means that, like, let's put some randomization into it when we're building something programmatically. So player enter, if you're collected, enter out. Otherwise, set frame to 0. And we're changing our sprite collection that we can play back instead of idle animation to collected. And then what that just means is token controller will play back the collected animation sequence of sprites. And if there is if the controller is not null, then collected is true. So sometimes when there's one line of code, you don't put curly brackets. So it's kind of a lazy convention. I do it too sometimes, but this is the same as just saying this. Like when there's no curly brackets, it means just execute on one line of code and keep going. So if we have a controller, say collected is true, and then schedule player token collision. Okay, so token controller will just say, so eventually this will be true, you know. Basically what happens is it looks like it needs to play through the collected animation first. So the token will say, instead of playing this animation, play this one, the collected animation. And it looks like that. It just disappears. But once we hit there, so we keep playing these frames, and eventually it looks like the length, this gets set to null somehow, because it says, hey, if collected is true, that was, I saw that. This right here, collected equals true, and the frame that we're on is equal. Oh, I see. And the frame that we're on is the last frame of the animation. Gotcha. So if we play through collected, we go here, 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 and we're right here, which is that. Then we can set the token to false, make it disappear, and set this array element to null. So you see here, like if we ever stumble upon it again, it's null, we'll just skip it. Cool. And so that's how tokens are. And let me jump over to, if there's any questions. I'm wrapping up platformer. But now let's move to the tile mapping. So this one, it felt weird to me. Usually I just had a lot of experience with these things. I could kind of intuitively just figure something out, but then this tile mapper kind of tripped me up. It didn't feel natural to me. But basically what you do is, to start the whole chain of events, is you create a tile map. Somewhere in here. Tile. Okay, here we go. Tile map. You just create one of these tile maps, and that's what creates this grid. So when you create a tile map for the first time, it's going to create this game object that has this grid, and then you set your cell size layout, like how big do you want each cell is each little square. And then it'll create one child game object that's got this tile map and tile render. So if I zoom out, there's actually like 4. And the level is like what I'll focus on right now. But now we have a tile map, and we have the tile map render, and this one had the tile map collider added to it. So it creates a collider on like the outer boundaries of the tile map. Now at this point, you can open up the tile palette system. I'm not going to create a new tile map, but you go through and you say, okay, what happens is you have these sprites. These are environmental sprites, and you create these tile assets from them. So they look just like the sprites, but they're like formatted to be used in the tile system. And I thought it was this little thing here, this like grid, This is just saying, this is just like showing you what all your tiles in your palette look like. So some of them are about buildings, some of them are about hills, clouds. But it's actually kind of funny. It's these little things here that make up a majority of the level. It's like here's the inner part of the level, and here's like where you walk, and here's an edge, and here's like some shadow areas, and that little part of this whole palette, as I move around the palette, that is like 99% of this tile map right here. So it's funny. So when you're ready to like edit, you can delete and move and then paint new stuff. But basically what you do is, I think it said focus on tile map. You just like focus down on the one tile map you want to work with. And I think I go into like the select tool. Yeah, go into the select tool. And when you select a tile, this is what it looks like. You have to use the inspector. And it says, hey, this is the tile, the ground tile. It's it'll point to the asset that it's referencing. And it's this one right here. If I click here, notice it says tile ground. If I click there, it's tile ground top. And these larger pieces, so you can grab one within your little palette and you can move it. Basically, your little palette is like a mini scene. This is what tripped me up. It's a little weird. You have to anyway, you can select in your tile palette and you can paint that. So I'll just paint it back. But if you select something out in the real world, or out in your level, I should say, and you can move it. Notice it's like popping when you use this boot. This is what I was looking for last time, like the snapping. Notice it's not doing these like in between parts. It's snapping to the grid, so you can move stuff around. You can swap out its tile. You can delete it. You have to delete selection. You could like rotate it and move it if you wanted not snapping for whatever reason. Scale it, transform it. So you use these things here. You can like insert like a whole row of empty row. It's kind of like a big grid system with like rows and columns. And swap it out. But normally you pick stuff in your little palette, and you could just start painting with it. Now the larger objects in your palette are a little weird. So notice I'm clicking, it says none, and I seem to be clicking on the tree. You actually have to get like the center of it. Be like, oh, this is a tree. Okay. So the same with these larger objects in your palette. Like, I don't know, they should have like some little icons to designate like what's the center of it. But here, this is a cloud. It's like only this little part here is a cloud, even though it's painted beyond it. You click your paintbrush and paint clouds. But these clouds probably belong on like the background layer or whatever. But anyway, I was having fun with this. So I was like, oh, what about this big round hill? So you have to like use the select tool to understand when you hit like the actual active tile, and then you can go into like the paint mode. It's like, oh, I want to put a bridge over this valley. Anyway, so you can modify. What I really want you to do is you can edit and modify these tile maps to make the level. So now when I click on level, the collider got updated, and so now we have a collider here, and I don't fall into the hole. And for some reason so that's why you can't put clouds on low, because they have a collider. They need to go in the background. You probably jump and hit them. Let's see. Actually, why don't I run to this tree? It's kind of interesting. Maybe I'm a little like these. Technically, there's colliders. Yeah, I am hitting these clouds. Interesting. But I know that there's a collider like on this fence and tree, so I don't know why I'm not like hitting that. But Oh. There's something with the player logic doesn't like how I hit this. This right here is like making him go into this slow jump thing. So there's something wrong, like something with the player, that kinematic object, that animation controller, where it's checking, it's not anticipating like a little slope up like this. You see he's getting stuck here. So if you did want something like this, then you got to go into your code, your player code. You got to mess around with it. Like why at this little ramp area is he getting stuck? Oh, nice. Went up there and got me. Cool. So that is everything with the platformer. So we kind of did a dive into what the 2D gaming system is like in Unity. So is there any questions before I wrap this up? Cool. So I'm going to put this project to bed. So I'm going to close out of my stuff. And I'm going to open up first person shooter. Hopefully you've got it open by now. So while that's opening up, let me just look at our schedule here. All right, so we're starting first person shooter about here. First week. So we're going to have 3 weeks, definitely have 3 weeks. Our quiz is on the 8th. So what do we, how much time do we have? About 15, 20 minutes. So I'll get started in first person shooter, but we really have 2 full weeks of first person shooter, and then we'll have our quiz. So just so you know, March 8th is quiz 2, and then the week after that is spring break. This should really come up. Yep. And then we have spring break this week, and then we move to section 3. And so then we still have half the class left. So we still have 3 weeks. We'll probably do section 3. I would probably go section 3, probably like this. Like I'll probably wrap up first person shooter toward the end of section 3. And then have a week of the driving game, and then go into section 4. It's all going to be driving. Yeah. So that'd be nice. That'd be nice transitions. Cool. So we'll have definitely enough time to break down these 2 games. All right. Let's give it a minute for it to open. Also, if you had any questions about platformer or first person shooter, now's a good time while we wait for it to load. All right, first person shooter. Um, assets. Looks like we have some add-ons. Looks like oh, that's interesting. I've never dug in. Okay, these are all the add-ons I see on the asset store, like sniper rifle and stuff. I never got into them. Interesting, they're available now. So here's the first-person shooter. Here's all the main content we'll be assets we'll be getting into. You see it's broken down nicely. Mod assets. So not this. This might be stuff that's borrowed and used into the main first-person shooter. I just want to see if the add-ons have any scenes real quick. No, these are just like the sniper rifle. You just kind of, yeah. It's a whole. Oh god, it's not. It's like I thought there'd be a scene showing how to put everything together. There's a README. Doesn't help much. All right, nav mesh components. So nav mesh is for AI navigation, rendering, some of the higher level pipeline stuff. Scenes is empty, sample scenes worthless. Text Mesh Pro is just for better text. So here we have our scenes. Okay. So this is interesting because we have 5 scenes. And I bet if I go into build settings, yeah. Okay, intro, win, lose, main. Intro, win, lose, main. So secondary is pulled in. So whenever you have more than one game scene, like if you're ever building an actual game and you're building it out to a platform to test out, like Windows or something, you actually have to pull in all your scenes, your Unity scenes that you want like to transition between while the game is running. And the first one is what will be loaded up when the player like opens up the exe or whatever. So this will open up intro menu. So why don't I'll just go to intro menu. Why don't I just play the game and see what happens? Okay, this is the intro menu. So we have some like a background, illustration. We can the controls. So we got some UI. An image pops up, tells you the keyboard controls and the gamepad controls. Sounds good. I don't think I've ever used the jetpack. Try that. And then we're in the intro. So we click play. So you can see it over here. Intro. Some game objects. Don't destroy means this is a game object that got loaded up with the intro menu, but it's saying, hey, when we swap to another game scene, for example, main scene, don't destroy this. Some stuff like gets carried over and comes along for the ride. Some stuff gets deleted between game scenes. So I click to play. Takes a little bit to load up. All right, usually when I saw compile shader, usually for the first time it's going to take a little bit longer. So notice in the hierarchy now, we have main scene. We have a completely different Unity scene, but we still have that don't destroy. This thing came along for the ride for whatever reason. All right. So now we're in main scene. I've got sound effects turned off, but I got a laser pistol, and in the UI, looks like at the top we have some type of compass showing me where the enemies are, my orientation, and the top left I've got goals, objectives, tab key to go into a pause menu. This isn't another Unity scene, it's just pausing the time and opening up the UI. Bottom left is health, and bottom right is pistol. And you can, looks like I got auto fire. And the 3D model of the gun is animating, and it's telling me like how much ammo or fluid I've got besides looking at the meter at the bottom right. And holding down the right key goes into like aiming, sniper aiming mode. And I'm pressing space to jump. I guess you have to collect the jetpack, because I don't have it right now. And C to crouch. And shift to run. I think that was everything. Okay. Controls. switch weapons. Okay. I don't have any other weapons. Cool. And I got my sights in the middle. And some enemies are patrolling, and then they get alerted, and they start moving towards me, and then this one happened to die before he did anything. I don't. It's just like a special. Yeah, didn't seem to do anything. Looks like I'm 1 out of 2 destroying the enemies. Got some health. It's just a particle. So we have a whole world around me. There's some particles floating up. I guess it's part of this lava field. So this whole thing is usually just like a big illustration. Yeah, but it has some like particles. Oop, I fell off. I died. I hit some type of kill zone. Dead. Oh, okay. Now I go into the lose screen. Completely different. You can go into intro or just jump back into main. I'll jump back into main. This time I'll let him. Okay, let him follow me. And he shoots me every once in a while. Alright, collected health. I don't know what that icon means. Looks like it's a big empty space. I guess you can build some stuff out here if you want to. And then here's a completely different enemy. It's like a big turret. It shoots a lot more. Whoa. Let's see, can cheat. Yeah, you can hit him. Yeah, you can hit him without him hitting you. Alright, so all objectives completed. Freeze me out. I can't do anything. Now I'm in the win scene, and now I can jump back into main scene or jump into intro. So you see I'm navigating back and forth with the UI between these 4 scenes. Alright. And I can play again if I want to. And just so you know that there's a secondary scene. And this one just has some jumps and a few more enemies, and it plays with some different weapons. So now I got a different weapon, a disc launcher. I'll swap to that. So it's like a grenade. Okay, I've got like an arcing graphic. Yeah, tries to show me how I'm shooting my grenade. If I remember right, there's like, oh yeah, there's like a little secret down in here. That was the shotgun. So I'll switch to the shotgun. And how do we get this way? So it's this way. These guys are kind of far away. Yeah. Launch a grenade at them. Whoa, that goes pretty far. Nice. Nice shotgun. So it looks like it's a proximity thing. Like even though I was sneaking up behind the enemy, he knew once I got within a certain distance of him, he knew I was there. So it looks like they just have like a big sphere around them. Oh no. Oh, the shotgun takes too long. Nice. Done. Cool. So that was the secondary scene. And let's see if it, yeah, oh, it does plug into the others. Okay. So that's the structure of the gameplay, and I kind of broke down what I think is happening, how everything works. And it's going to take us a while because we have got 5 scenes to break down. There's a lot going on in them. I'll stop here real quick. Is there any questions as I did that kind of playthrough of the first-person shooter? is the only thing I think I'm going to get into is maybe the UI for the intro menu for today. Okay. So the intro menu. So if I keep zooming out, here it is. Okay, it's this big massive UI. So we have the main camera. Is what the player looks through. Nothing change about it. We have all the UI, game objects UI. This is all the UI elements. You have to start with a canvas, then you have stuff like you can put in images or text or toggles, sliders, buttons. This thing has, it looks like an image and 2 buttons. Let's take a look. So underneath the canvas, this canvas happens to be set to screen space, and it's just overlaying on top of the camera. So it's super big and it's off to the side. So if I just create like a little 3D object, like a sphere, just put out world space 0. You zoom up on it. Notice how the UI is kind of like not overlapping everything. It's kind of big and off to the side, and they do that for a reason to like hopefully keep the UI out of your game level. So this is a screen space UI. It only gets rendered to the camera. It's not supposed to be in world spaces such. So some elements we have here, we have a background image. So we get into the canvas. Some important things to note is that then we move to a rect transform, a rectangle transform, as opposed to a normal transform. So when we're in screen space, like as I move my mouse over the screen, notice my mouse is moving around a rectangle. So it's 2D space, screen space versus world space. And in screen space, we're only interested in the vector 2, X, left, right, and Y, up and down, to know where the mouse is on the screen. So when we build UIs, we're in 2D space, basically, and we have a different type of transform. And some of these things we'll learn about, anchors and positioning. Not too much, but enough for you to like know how to break stuff apart, and you can read if you want to learn more about UIs. But ultimately, so we have a rect transform. Basically, it's just saying place this image at the center of the UI. And here we have an image. So it's a raw image as opposed to an image. I don't really know the difference between the two. I do usually use images, but it seems like this is just a big illustration somebody made, and you just slap it in as a texture. So one thing to note, that's now that we transitioned from 2D to 3D, is when we bring in a big change is when we bring in images, PNGs, texture. This one is a sprite. That's interesting. We're kind of using default, not sprites, but I guess for UI work, maybe use sprites for UI. Usually I use default for UI too, but see like this skybox here, this one is default. That's probably because it's wrapping around. That's probably like the really big one that wraps around the whole world. Okay, well, for the UI, they brought it in as sprites, but you can also bring it as default. So it is an image component, and we're just slapping an image onto it so that we can see it in our view. And I guess the difference with raw image is there's no material. So we've yet to really dive on what are materials and shaders, and we're definitely not doing that today. But it's interesting that I guess a raw image doesn't need a material. Sure. So underneath this image, we have a vignette. It's kind of hard to see, but if I ramp it up, a vignette is known in movies and games. It gives that darkening, that round, that like it's a big oval with the soft darkening, and they use it for like theatrical, make it look more intense purposes. So anyway, it's a vignette, and all it is this. It's just an image again, and it's this type of image where it's got like there's coloring on the edges, and this darkening really means like it's alpha, like it's more transparent, and then it gets more opaque outwards. So anyway, that's a vignette. Make it look stylish. And a title. That's interesting. You type in the title so you can name it. say it's my game. I don't know why they have a title there, but they fill it out. But so this is a text. Notice rect transform and text mesh pro. So it's just a text element. You can just type in your text. You can say, the beauty of it is it's like super sophisticated. You can select a bunch of fonts. You can, just like a word processor, like you can make italic and bold and different positions and wrapping and whatever. So just think of it as like a high-end text capabilities. What's important is in rect transform. So position X, notice as I move it to negative and to the right, it goes positive to the right, and position Y up and down. Z doesn't, you don't see it. It is moving it forward and backward, but when we're rendering UI, it's like orthographic. You don't notice this perspective distortion. So this should always be just zeroed out. Now within height are important. Usually you want to like resize it to your image, but for text, it's actually important for like when it wraps around or gets cut off. So as I add width to it, notice it like, oh, you really want this on one line or two line. So width is important for like really setting up width and height, you know, like your text box. And anchoring has to deal with the fact that like you don't know the screen resolution that your player computer monitor or phone or whatever. And so UIs are really difficult because they have to like look nice on many different computer screens and aspect ratios. So once you like do a general positioning, I will just say that you have these anchoring systems. So like if I pin it to the bottom top right and I say, okay, this text, no matter how it gets repositioned, should like always be at the top right. Now watch as I kind of move my preview so it messes up like the size of the screen that's being rendered, and it kind of stays right at the top. Like it looks nice no matter what the user's rendering it to. It kind of looks good. But if I don't pin it, is it the anchor positioned? Let me just mess with this real quick and see if I. Oh, that's being pinned to the corner. Let me pin it to the other side. It should kind of act. No, it's not off topic. Do Text Mesh Pro. Because it's just a lot more sophisticated. You'll get better results than the legacy. I'm trying to. Oh, okay, got it. Free aspect. So it was clamping to like a certain aspect ratio. But if I do free aspect, so now let me like pin it in the top left and see how it like it stays. Yeah, your aspect ratio is getting really messed up. Everything like looks wrong, but it's kind of trying to do its best. And so these are clamped to the bottom middle. But if I make it something ridiculous, like yeah, if I clamp it to the bottom right, notice how it's trying to stay toward the bottom. So when you place your UI elements, hopefully everyone plays at a certain aspect ratio that like full HD that like you're supposed to be played at. But then you don't want stuff to be like buttons falling off like the screen and then they can't click them and then people can't even play the game. So it's really important to like place your stuff appropriately and position them and then anchor them to the correct little corner, or if they're dead center, anchor them to the middle, so that no matter what aspect ratio your player is using on their monitor, it tries to, it might look bad, but at least it's like usable. At least it's kind of legible and you can still kind of play even though it's all jacked up. So anyway, that's your brief introduction to rect transform, to anchors, pinning to the correct corner where the stuff is. Yeah, there's like stretchy things, like you can make stuff stretch in different directions and stuff. I don't get that advanced. I'm like, these are my images, these are my text, these are my buttons, and wherever they are in the screen. So for example, the start button, this, notice the play button is like clamped right at the bottom middle. It's like place it here, make it this size, make it nice and easy to press, and clamp it or pin it at the bottom so that it's always like on screen toward the bottom, no matter how screwed up the computer monitor is. You can't control what the user is using, so you have to do your best to accommodate all these crazy situations. And I'll move on to the start the buttons and stuff next week. So anyway, I'm going to stop here. Let me know if you have any questions.